Good morning, dear students. My name is Ferhan Mazher, and today is 15th April 2021. The day is Thursday. Right now, I am with the 11th Cambridge class, and today we are studying the subject of physics. This is O levels physics. The code is 5054. Today, we have set our hearts to solve an MCQ paper. This is paper 1, a very old paper. This is October November 2003. So let's start this paper, and the very first question coming on your screen is question number 1, and he says one oscillation of us one oscillation of a swimming pendulum occurs when the bob moves from x to y and back to x again. Using a stopwatch, which would be the most accurate way to measure the time for one oscillation of the pendulum? You see, if you want to find out the time period of the one oscillation, we never directly time it. We never directly record the time of one oscillation. What we will do, we will swing it for 20 oscillations. We will note down the time for 20 swings. We will note down the time for 20 oscillations. And whatever the time you get on the stopwatch, then you divide it with 20. So clearly B is the right option. Question number 1, B is the right option. Time 20 oscillations and divide by 20. The next question is question number 2. Which of the following defines acceleration? Acceleration is the change in velocity divided by time taken. Acceleration is the change in velocity divided by time taken, and A is the clear choice. Change in velocity divided by time taken. A is the right option, sir. So question number 3 is on your screen. He says, question number 3 is on your screen. The graph shows the movement of a car over a period of 50 seconds. What was the distance traveled by the car during the time when it was moving at a steady speed? It's a very important thing. When it was moving at a steady speed. So look at your graph and check when it was moving at a steady speed. So you can see here it's moving at a steady speed from 20 seconds to 40 seconds. The car was moving with the steady speed. You want to find out the distance traveled. The distance traveled is equals to the area under the speed time graph. And let me show you. The area under the speed time graph will be like this, and I can find this area. It's the shape of a rectangle. So its length is 20 and its width is 10. So simply multiply 10 with the 20 and you will get the answer. I've done this on a paper. Let me show you my work. And question number 3, you can see the area under the speed time graph is equals to length multiply width equals to 20 multiply 10, and it will be 200 meter. It will be 200 meter. Let me show you. 200 meters. So do we have this option? Yes, we have. C is the option. So question number 3, C is the right option. Okay, the diagram shows a cyclist leaning over in order to cycle around the corner. Which force is necessary to maintain the motion around the corner? Whenever you turn in a corner, you need centripetal force. And the direction of the centripetal force is always towards the center of the circle in which you are turning. So because it's leaning to the left, which means that the center of the circle will be also on the left side. So clearly only A is the option. Question number 4, A is the right option. Then we have next question. That's question number, okay, question number 5 is on your screen. And it says a box X full of large granite rocks is weighed. An identical box Y full of small granite chipping is then weighed. Which box weighs more and why? The small granite chipping will weigh more, and the reason will be there will be less gaps between the chippings. Here in the larger rocks, there will be lot of gaps and there will be lot of air in them. So C will be the reason. I think question number 5, C will be the option. There is less air in the box Y because there is less space between the granite chippings. So C is the right option. It's a little tricky question. The density here and the density here is same thing of the granite. Question number 6 is showing up on your screen, and it says which property Which property of the body cannot be changed if a force is applied? The shape can be changed, its size can be changed, its velocity can be changed. One thing which you cannot change by applying force is the mass of the object. So question number 6A is the right option, sir. Which diagram correctly shows the addition of a 4 Newton and a 3 Newton force? You see here you are applying the triangular law. So when you apply the triangular law to add up two forces, you put the first force, and at the head of the first force you put the tail of the second force, and the resultant is by joining the tail of the first force with the head of the last force. Try to understand once again. It's a triangular law. If you are using triangular law to find the resultant of two forces by adding, and you are using triangular law, you take the first vector. On the head of the first vector, you put the tail of the second vector, and for resultant, you join the tail of the first vector with the head of the last vector. So clearly, A is the option. Question number 7, A is the right option, sir. Question number 8. A student who weighs 500 Newton climbs up a flight of stairs 10 meters high in 5 seconds. What power does he develop? Power, the formula of power is equals to work divided by time. And in this case, the work will be weight multiplied the vertical height gained divided by time. And the weight is 500 Newton and the vertical height gained is 10 meters. And that will be the work done 500 multiplied 10, and you divide it with the 5 seconds. That will be the power. So clearly, question number 8, B is the right option, sir. A rock of mass 20 kg is traveling in space at a speed of 6 meters per second. What is its kinetic energy? The mass is given and the speed is given. And you know the formula for the kinetic energy is half mv square, 1 by 2 mass multiplied square of the velocity. I've done this on a paper. Let me show you my work. And here we go. Question number 9, kinetic energy is equals to 1 by 2 mv square. So it will be 1 by 2 multiplied 20 multiplied 6 square. And the answer will be 360 joules. 360 joules is the answer. So let's see. 360 joules is, oops. C is the answer, 360 joules. By mistake, I have highlighted the D also. C is the choice. C for cat. C is the choice. Question number 9, C is the right choice. Okay. Question number 10 is showing on your screen. The diagram shows to the same scale in the vertical section of a set of circular vessels, each containing the same depth of the water. If the vertical depth of the water is same in all of them, the same pressure of water will be exerted on the bottom of the vessel. Which of the following statement is correct? The water exerts the greatest pressure on the vessel. B, the water exerts the greater pressure on the vessel, base of the vessel. S, that's wrong. The water exerts the same force on the base of each vessel. No. The water exerts the same pressure on the base of each vessel. Yes. B is the right option, sir. Question number 10, D is the right option. If the vertical height here is same, the pressure exerted on the base of the vessels will be same. Here we go. Which graph shows the relationship between the pressure and the volume of a fixed mass of a gas at constant temperature? You know, if the temperature is kept constant, the relationship between the pressure and the volume of the gas, they are inversely related with each other. So remember, mathematically remember it, that if the two quantities have an inverse relation with each other, the graph will be like this. Don't forget this fact. If the two quantities have a relationship, inverse relation with each other, their graph will look like this. Okay. So C, question number 11, C is the right choice. Assuming the temperature remains constant, which combination correctly describes the volume and the shape of a gas or liquid? For gas, the volume is fixed. The volume is not fixed and the shape is not fixed. For liquid, the volume is fixed but the shape is not fixed. So clearly, if you look at the no, I don't know. Yeah. Clearly, B is the right option because I cannot highlight it properly. So B is the right option. Question number 12, B is the right option. The gas has not fixed. So, my dear students, I am back because there was some interruption and I don't know what happened with something happened with the internet and all of a sudden the call was disconnected. So we were doing October, November 2003, paper 1. This is physics 5054. And we were discussing question number 14. A 2 kg mass of copper is heated for 40 seconds by a heater that produces 100 joules per second. The specific heat capacity of the copper is 400 joules per kg per Kelvin. What is the rise in the temperature? You see, I know the rate of heat transfer, that's 100 joules per second. I know this happened for 40 seconds. So I will multiply 40 with 100 joules per second and I will get the amount of heat provided to the body. And then I can apply the formula heat is equal to mc delta theta. And from there, I can find out the value of the delta theta, that is the change in the temperature. So let me show you my work. I've done this on a paper. Here you go. The work is showing on your screen. So I know the heat will be the power multiply the time, that's 100 multiply 40, and that will give you 4,000 joules. And this heat is used to raise the temperature, so it is equals to mc delta theta. M is 2 kg, the C is 400, and delta theta I want to find out. So I will make delta theta alone, and it will be 4,000 divided by 800, and the answer will be 5 Kelvin. So the rise in the temperature will be 5 Kelvin. Rise in the temperature will be 5 Kelvin. So let's check what are the options. So here we have 5K. So rise in the temperature will be 5K. In a vacuum flask, which method of heat transfers are prevented by the vacuum? The vacuum can prevent conduction and vacuum can prevent convection, but the vacuum cannot prevent radiation. So clearly C is the option. Question number 15, C is the option. Okay, so the next question is showing up on your screen. The diagram shows the variation of the displacement of a wave with the distance from the source. And what is the amplitude? You see this is the displacement distance graph. From this graph, I can tell the wavelength, and from this graph, I can tell the amplitude. The amplitude is the height from the mean position, the maximum height from the mean position of the wave, or the minimum, the depth of the wave from the mean position. So clearly the amplitude is 2 centimeters. So A is the choice. Question number 16, A is the right choice. Okay, so the next question is question number 17. Okay, A ray of red light enters the semicircular glass block normal to the curved surface. Which of the following correctly shows the partial reflection and refraction of the ray? So A, B, C, D, 4 options. Here the reflection and the refraction should take place here. We have to check which one is the correct part. So let me show you my work. I've done this on a paper, and let's see. So you see here on all the 4 diagrams, I have drawn a normal. Here for the reflection, angle of incidence is larger, angle of reflection is smaller. So this is not the right path. This is again not the right path because the angle of incidence and the angle of reflection, they are not equal to each other. So B cannot be the option. Look at the C, the angle of incidence here and the angle of reflection here, they both are equal to each other, so it's good. But when the light entered from a denser medium into a rare medium, the light was supposed to bend away from the normal. But here you can see the light has bended towards the normal. So this cannot be the option. Here you look at here in the D option, the angle of incidence and angle of reflection, they are equal. For reflection purpose, it's good. When the light entered from glass into air, from a dense medium into a rare medium, it bended away from the normal. So I think that D is the best option, sir. D is the correct path. D is the right. So you see, you understand how do we decide on this? How do we came to know that which one is the correct path? So D is the right option, sir. So D is the right option. I hope that you have understood. This is question number 17. D is the right option. Okay. Question number 18 is showing on your screen. Let me increase the size. The diagram shows 2 divergent rays of light from an object O being reflected from a plane mirror. At which position will the image be formed? The image will be formed. I can prolong these rays. I will prolong this ray behind the mirror, and I will prolong this reflected ray behind the mirror. Where these 2 rays will intersect, there the image will be formed. So let me show you my work. I've done this on a paper also. Let me show you that. And here we go. You see, if I will prolong this ray behind the mirror, you can see I have prolonged it behind the mirror with the red ray, and this reflected ray I have prolonged it behind the mirror with the red ray. Where these 2 will intersect behind the mirror, there the image will be formed. So it means that the image of this object O will be formed on the location B. So the image will be formed on the location B. So this is the option. Question number 18, B is the right option. Question number 19, the human eye has a converging lens system that produces an image at the back of the eye. If the eye views a distant object, which type of image is produced? You know, the human eye has a converging lens and the image is produced on the retina. The image produced is real. The image produced is inverted. The image produced is diminished. The image produced in the eye is real, inverted, and diminished. So clearly the B is the right option. Question number 19, B is the right option. The next question, which of the following does not produce a sound wave? A sound wave, a bell ringing underwater, it will produce sound, you will be able to hear it. A gun fired in a room with no echoes, no, that's not possible. A hammer hitting a block of rubber, that will produce sound. An explosion in the outer space, yes, this will not produce the sound because you know that in outer space there is vacuum and sound need medium to travel. So when there is a vacuum around the explosion, the sound cannot reach you. So D is the option. Question number 20, D is the right option. Which of the following will prove that a metal bar is a permanent magnet? It attracts another. The confirmed test for a magnet is the repulsion from another magnet. You never conclude that something is magnet if it is attracted to another magnet. The confirmed test for an unknown object to be magnet is when it is repelled by another magnet. Okay, repulsion is the confirmed test. it repels another magnet. Yes, this is the right test. If it is attracted to another magnet, it might be only a magnetic material. So D is the right option. Question number 21, D is the right option. Oops. Question number 22, 4 metal rods are placed in turn inside a coil of copper wire. The table below gives the results of the experiment. Which rod would be the most suitable to use for the core of a coil in a circuit breaker? The core of the coil in a circuit breaker should be such that when the current is provided, it should become a strong electromagnet, but when the current is switched off, it should lose its magnetism immediately. So you see, when the metal rod and the number of paper clips picked up, when there is a current in the coil, number of paper clips will still attach when the current is switched off. You see here, I will choose that option, that when the current is provided, it picks up the maximum paper clips, but when the current is switched off, it should drop all the paper clips. So clearly, because that means it has lost its magnetic. So I think C is the right option. By chance, you see this highlighting has been gone wrong. So option is C, because when the current is provided, it picked up lot of paper clips, but when the current is switched off, it has dropped all the paper clips. So this is the best material to be used. So C is the right option. Question number 22, C is the right option. Okay, so on your screen, we have question number 23. A positively charged rod is brought close to an insulated metal sphere. Which diagram best shows the induced charges on the sphere? So if you have this positive, this end of this rod is positive. So this end should become negative, the other end should become positive. So I think C is the right option. Question number 23 is a very easy and straightforward question. C is the right option. Question number 24 is showing on your screen. How could the unit of potential difference? How could the unit of potential difference, the volt, also be written as? You remember the definition of the volt, that is the work done divided by the charge. Work done or energy divided by the charge. So that's the joules per coulomb. Joules per coulomb. So very easy, it's a fact, joules per coulomb. So D is the option. D is the right option. X and Y are lamps with filaments made from the same material. The filament of the lamp X is thicker and shorter than that of the lamp Y. When connected to the mains and switched on, which is brighter lamp and which has a larger resistance? You see, they are connected to the same main supply, which means they are getting the same voltage. If they are getting the same voltage, now the brightness will depend upon the amount of current flowing through them. The Y will have a larger resistance. But when the Y will have a larger resistance, the current flowing through it will be smaller. Whereas the X, because it is thicker and it is shorter, so its resistance will be lower. So the voltage it will getting the same, but the current coming from the supply will be more for the lamp X. So its power P is equals to IV. The power will be larger, so it will be brighter. The brightness depends upon the power. The brightness depends upon the power. So because the X has less resistance, so and they are connected, they are getting the same voltage. The both of them getting the same voltage. It means that the X will be getting more current. The voltage is same, but X is getting more current. So the power is equals to IV. So the X is getting more power. So that's why the X will be brighter. But the Y will have, the Y will have larger resistance. The Y will have larger resistance, but the brightness will be of the y, of the x, sorry. Brightness will be of the x. The x will be more brighter and the y will have larger resistance. So question number 25, B is the right option. Try to understand. I think we have got confusion because the x has shorter length and it is thicker. Its resistance will be lower. So the resistance of y is larger. That is decided. So y has a larger resistance. It is decided. Okay. Now because they are connected to the main supply, so they both are getting the same voltage. But because the x has the less resistance, so it will get higher current. Larger amount of current is coming to x. When it has larger amount of current coming to the x, the power will be larger because power is equal to IV. When the power is larger, then the brightness will be more. So the x will have more brightness and the y will have larger resistance. B is the option. I hope you have understood because I think when I was talking, so there was a little bit confusion. So, okay, next question. The next question coming on your screen. So, diagram 1 shows a resistor connected to a battery, an ammeter, and a voltmeter. The ammeter reading is 0.5 ampere and the voltmeter reading is 3 volt. A second identical resistor is now connected in parallel with the first resistor as shown in the diagram number 2. What are the ammeter and the voltmeter readings in the circuit shown in the diagram 2? You see, from here, I know the voltmeter reading in the diagram number 1. I know it's 3 volt. The current coming from the battery is 5 ampere. So I can find the resistance of this resistor. Then an identical resistor is connected to parallel to this. I will find what is the equivalent resistance of these two. And I know the same battery is connected here. So the EMF of the battery is 3 volt. And I can calculate how much is the current coming from the battery. I've done this on a paper. Let me show you my work. So here, try to understand. It's a little tricky question. In the diagram number 1, the resistance of a single resistor will be V divided by I, 3 divided by 0.5. That will be 6 ohm. And then in the diagram number 2, there were 2 identical resistors. They were connected parallel to each other. So that I can find their equivalent resistance. That is 1 by R equivalent equals to 1 by R1 plus 1 by R2. So 1 by R equivalent will be equal to 1 by 6 plus 1 by 6. And 1 by R equivalent is equal to 2 by 6. So R equivalent will be 6 by 2 equals to 3 ohm. So the total resistance of the circuit number 2 is 3 ohm. And the EMF, the same battery is still there. So the EMF of the battery is 3 volt. The resistance of the circuit is 3. So how much current coming from the battery? 1 ampere. So if you look at that diagram again, so this ammeter will read 1 ampere and the voltmeter is actually telling you the EMF of the battery. That will be still 3. So I think D is the right option. Question number 26, D is the right option, sir. Question number a 1 ohm resistor and a 2 ohm resistors are connected in series across a 12 volt DC supply. What is the current in the circuit? Very easy question. These 2 resistors, they are connected in series. So you can find their equivalent resistance simply adding them. R equivalent is equals to R1 plus R2 because they are connected in series. So the total resistance of the circuit will be 3 ohm and the voltage EMF of the battery is 12 volt. So we can find out the current coming from the battery. So the EMF is equals to IR. I will be equals to EMF divided by R. So it will be 12 divided by 3 and the 4 ampere. That will be the answer. I've written this answer also on the paper. Let me show you my work. So R equivalent is equals to R1 plus R2. 1 plus 2 equals to 3 ohm. So EMF of the battery is 12 volt. So EMF is equals to IR. I will be equals to EMF divided by R. 12 divided by 3, and the answer will be 4 ampere. So the current coming from the battery will be 4 ampere. And let's see. So 4 ampere, clearly B is the choice. Question number 27, B is the right choice. The cable to an electric fan becomes so worn that the live wire makes electrical contact with the metal case. The case is earthed. The plug to the fan contains a 5 ampere fuse. There is a current of 4 ampere when the fan works normally. What will happen? Because you see, when the current will run to the earth and the fuse will not be affected. No, the fuse will melt and switch off the circuit. Yes, this will happen. This will happen, and I think the metal case will become live and dangerous. Yeah, the metal case will become very hot. You see, B is the best option. That what will happen? The fuse will melt and switch off the circuit. Then we have next question. A small heater operates at 12 volt 2 ampere. How much energy will it use when it runs for 5 minutes? A small heater operates at 12 volt 2 ampere. How much energy will it use when it runs for 5 minutes? Electric energy E is equals to IVT. E is equals to IVT. Very simple. You just have to put the values. Let me show you. Yeah, on your screen, I think it's showing energy is equals to IVT. Energy I is 2 ampere, V is 12 volt, with time is 5 minutes. So I will convert it into seconds. So it will be 5 multiplied 60. So that will be 7200 joules. So 7200 joules. So D is the option. Question number 29. D is the right option. Which of the following has no effect on the size of the turning effect on the coil of an electric motor? Which of the following has no effect on the size of the turning effect on the coil of an electric motor? The size of the current, it has effect. The direction of the current, it do not have the effect on the size. The number of turns in the coil, it has the effect on the size. The strength of the magnetic field, it has the effect on the size of the turning effect. So B is the right option. Question number 30, B is the right option. So question number 31 is showing up on your screen. The diagram shows a beam of electrons entering a magnetic field. The direction of the magnetic field is out of the page. It is out of the page. So in which direction does the deflection of the electron occur? You see, the magnetic field is out of the page. The electrons are going towards left. So I will apply the left-hand rule to find the deflection. So, but remember one thing, the left-hand rule is not about electrons. It is about positive charges. So whatever the direction I will get, the answer will be opposite to that. Okay. So I will apply the left-hand rule. The left-hand rule is you take your left hand, you stretch these 3 fingers in such a way that they are mutually perpendicular to each other. For example, this thumb, that is called the force, and this index finger, that is the magnetic field, and this middle finger, that is direction of the current, but that current is conventional current. So the magnetic field is coming out of the paper. It's coming out of the paper, so it will be like this. You see, the magnetic field is coming out of the screen towards me. The electrons are going in this way towards left. My thumb is pointing upward. But this law is not for the electrons. It's not about the negative charges. Because here my thumb is pointing upward because these are electrons. So they will be deflected downward. They will be deflected towards the bottom of the page. Towards the bottom of the page. So I think question number 31C is the option. I have also made this diagram to show you. So here we go. You see, I represented the magnetic field with the dots. Dots mean that the magnetic field is coming out of this page or this screen. And but that law which I use, that left hand rule, that is about the conventional current, not about the flow of the electrons. So I can do by another manner. Suppose if the electrons are going towards the left, that it means that the conventional current will be going towards the right. So suppose the electrons are going to the left, so the conventional current should be going towards the right. So apply this left hand rule. The magnetic field is coming out of the paper. The magnetic field is coming out of the paper. This finger is coming out of the paper, and this is the conventional current. Then my thumb is pointing downward. Then it means the conventional current or the electrons, they will be bended towards the bottom of the page. So this is how you do it. A little tricky thing. And let's go to the next question. Question number 32 is on your screen. Why is electricity transmitted along the power lines at very high voltage? We use a step-up transformer to increase the voltage before sending the electricity into the transmission line. We increase the voltage because then the current reduces, and when the current reduces, then the power loss, which is given by the formula P equals to I square R. When the current reduces, the power loss or the energy loss in the transmission lines is reduced. So D is the right option, to reduce the loss of energy. Question number 32, D is the option. A small coil is connected to a galvanometer as shown below. When the magnet is allowed to fall towards the coil, the galvanometer pointer gives a momentary deflection to the right of the zero position. The magnet moves through the coil, and as it falls away from the coil, the galvanometer pointer, when it is entering the coil, it deflected towards the right. When it will be leaving the coil, it will be deflected momentarily towards the left. B choice. Question number 33. B is the right option, sir. The galvanometer should show deflection in the opposite direction, whatever direction it showed in the first moment. A simple AC generator produces a voltage that varies with the time as shown, and you see in 2 seconds this wave is completed, and the amplitude of the wave is 1 volt. The amplitude of the wave is 1 volt and the time period is 4 seconds. Which graph shows the voltage varies with the time when the generator rotates at twice the original speed? If you will, the speed of the rotation of the coil, you make it double, the amplitude should become double. Originally it is 1 volt, then the amplitude should become 2 volts. And when you double the speed of the coil, the time period will become half. The wave should be completed in 2 seconds. The frequency doubles. In this portion, now you have just 1 wave, then you should have 2 waves. So, A is the option. A looks the right option, sir. You can see in that gap now we have 2 waves. The time period has become 2. The amplitude has become doubled. The rest of the, let me show you source code. You can have a look at these for yourself. I think A is the right option, sir. The amplitude should have become double. The time should have become half in the same duration. When there was only 1 wave, now there should be 2 waves because the frequency will double. A is the option. Okay, so let's move to the next part. The diagram shows a circuit. What are the components X and Y? This X, this is light dependent resistor. Light dependent resistor, LDR. LDR. And this Y is a variable resistor. We also call it rheostat. So X is the light dependent resistor and the Y is the variable resistor. So D is the choice. Question number 35, D is the right choice. The following trace is shown on the screen of an oscilloscope when it is connected to a transformer. The scale is set at 5 volts per centimeter. What is the value of the peak voltage? You see, this is the mean position, and from the mean position, it has gone up 2 divisions. And each centimeter represented 5 volts, so there are 2 centimeters, so it has gone up 10 volts. So C is the option. From the mean position, how high it went? 2 centimeters. So each centimeter is representing 5 volts. So 2 centimeters means 5 multiplied 2, that will be 10 volts. So C is the option. Okay. The diagram shows a circuit with a potential divider joined in series with a fixed resistor. What are the minimum and the maximum readings that can be obtained on the voltmeter when the potential divider is adjusted? To see, if you make it here, this sliding contact, if you bring it here, then in the potential divider, this will be the R1, this will be the R2, this voltmeter will be taking the reading from the whole 6 ohm resistor here. 3 volt, 2 volt will be provided to this, 2 volt will be provided to this. So the maximum reading it can take is 2 volts. If you move this sliding contact here, if you bring it here, then the voltmeter will read 0 reading. So A is the answer. So the maximum reading this can measure is 0, and the maximum, the minimum reading it can measure is 0, and the maximum reading it can measure is 2. A is the option. X and Y are 3 types of radiations. X is almost completely absorbed by a 3 centimeter lead, but not by 5 millimeter aluminum. X is gamma rays. X is gamma rays. Y is almost completely absorbed by 5 millimeter aluminum, but not by thin card. So Y is beta particle. So X is gamma, Y is beta, and Z is absorbed by thin card. That's alpha. It's a famous experiment. You know, the gammas, they cannot be stopped by the aluminum. So what are X and Y and Z? The X and Y and Z. X is gamma rays, Y is beta rays, Z is alpha particles. So D is the choice, sir. Question number 38, D is the right option. Question number 39 is showing on your screen. The nucleus of a nitrogen atom can be represented as this. The nucleus of this atom consists of. So there are 7 protons. And how many neutrons are there? 14 minus 7, that will be also 7. So there will be 7 protons and 7 neutrons in the nucleus. 7 protons and 7 neutrons in the nucleus. So clearly the B is the right option. Three nuclei P, Q, and R have proton number, atomic number, and nucleon number are shown. The proton number is 43, the nucleon number 93, 43, 94, 44, 94. So which nuclei are isotopes of the same element? Which nuclei are the isotopes of the same element? You see, the isotopes should have the same proton number, and their nucleon numbers will be different. So they should have the same proton numbers, and their nucleon numbers can be different. So clearly the proton number same is here. Oops, oh my God, I highlighted the whole thing. So P and Q have the same proton number, and so it means that P and Q only. P and Q only. A is the option. P P and Q only. They have the same proton number, different nucleon number. So it means they are the isotopes of the same element. So my dear students, today, and we have reached the end of this paper. And today we have done October-November 2003 5054 paper 1. It's a MCQ paper, and we are trying to solve very old papers. So I think that this has been helpful to you during this making of this video. You know, there was once there was all of a sudden the internet went off, and so due to that we might have a little problem. But I will join the two videos together. If this video is helpful to you, and if this is helping you to improve your grades, don't forget to subscribe to my YouTube channel. Don't forget to subscribe to my YouTube channel. Also recommend these videos to your friends. Okay? So if you have any comment, feel free to comment. So everybody, so thank you very much, everyone. So I think enough for today. So thank you very much, everybody, and have a good day, and God bless you all.